Okay, we're going to look at another problem from section 2.7 in our textbook, revolving related rates. Here we indicate that we have two sides of a triangle. They are fixed at 4 and 5 meters. So let me draw my triangle here. So I'll call that 4, that 5. The angle in between them here, which I'll call theta, so is increasing. So that's a d theta dt is equal to 0.06 radians per second. We want to find the rate at which the area of the triangle is increasing when the angle, this theta, is pi over 3. All right, there's a couple of ways to look at this. First, we don't have a right triangle here. We're not given that information. So we can use a formula that says the area is equal to 1/2 AB times the sine of C. And so remember, when we label a triangle, right, we have lowercase letters for the sides, and then the angle opposite will be a capital letter, right? So here we have our AB sine C, so it's the angle in between, right? We could have AC sine B, C or CB sine A, doesn't really matter, just a combination of two sides and the angle between. But let's say you didn't remember that and you're trying to find the area of this. Okay, so what I would do is I would drop a perpendicular. If we call this our base, that's our height. We also know the area of a triangle is 1/2 base times height. So by dropping a perpendicular, I have formed a right triangle here. And we know that the relationship between this angle, the opposite side, and the hypotenuse is the sine, right? So the sine of theta is equal to h over 4. So h, the height, is equal to 4 sine theta. Well, let's look here, right? If we look at substituting 4 sine theta for h, here's our base, which we know is 5. We end up with 1/2 base 5, height 4 sine theta. Well, if we had followed this formula, we would have 1/2 4 5 sine theta, or C, the angle in between. So that's exactly where that equation comes from, but you can always derive it on your own, just dropping a perpendicular to the base and then using our right triangle trig. So these sizes that we know are fixed. So 4 times 5 is 20, divided by 2 is 10. So we have 10 times the sine of theta. And they're asking us to find the rate at which the area is increasing. So that is going to be dA dt equals 10. So now we're going to have to do implicit differentiation, right? A is not written as a function of time, neither is sine and neither is theta. So we have the derivative of sine, so we're using a chain rule here as well. The derivative of sine is cosine. So we have cosine theta times, and this is where the chain rule, that link, times d theta dt. Okay, and we already know d theta dt over here. They've given that us earlier. Here's our theta. So the only variable left will be dA dt. So we have dA dt equals 10 times the cosine of pi over 3 times 0.06. And so the cosine of pi over 3 is 1/2. So 5 times 0.06. And that gives us 0.3. That's our dA, the rate of change of area, dA dt. And our units here, because we are area, that's going to be a square unit. We're given meters, and we're given seconds here as part of our rate of change of an angle. So we know we have meters squared per second. Hope that helps, and we'll see you soon.